So hi everyone. Today we'll be looking at a topic from fluid dynamics, which is rotating container. Now, for any rotating container, we'll be analyzing what sort of curve will be there and how that curve will behave. We'll be finding the equation of the curve and further on talk about the forces acting on multiple elements of the container. And of course, we'll be ending this video with a derivation of the equation of the fluid inside the container. Now for the rotating container, we know that the fluid present in it undergoes a pressure difference due to the centripetal acceleration provided. Now the centripetal acceleration, if you take it as a whole, is non-uniform because we have distance varying linearly. But if you consider an element, the value of this radial acceleration will be x times omega squared, where x is the horizontal distance we have of an element from the center of the container. And also, since the centripetal acceleration is some x times omega squared, that means the centripetal acceleration is dependent on the square of the angular velocity, the constant angular velocity. The curve is ought to be a parabola for a second degree equation. So we have a parabola for this rotating container. Now we'll be deriving the equation of the parabola with the help of all the clues. Now for the derivation part, we'll be assuming an element of width x and situated at a distance y, vertical distance y from the very top. We'll be considering the center of mass to be at a distance of x by 2 from the center of the container and assuming the linear mass density for the element. Right. So we are to find the summation of all of the forces and equating that to mass times the radial acceleration or the centripetal acceleration for the center of mass, only, and not at any other point for the element, right? In order to analyze the forces, we'll have to figure out the pressure at the left point and the right point. Now we know that there is some sort of ambiguity in height. Let us call this ambiguity as y, the delta h as y. Otherwise the pressure would have been same at both of the coordinates, both of the points, right? So let us call the atmospheric pressure as P naught, and the pressure at the left point is going to be P naught, and the force at the left point is going to be P naught times the area, where area is the cross-sectional area of the element. And at the right point we'll have the pressure as P naught plus y rho g times the area. So we know that there is an imbalance of the forces which will result in a centripetal force or a centripetal which will provide a centripetal acceleration. The converse is also true, that the centripetal acceleration given to us due to the rotating container with an omega provided us a difference in pressure, hence which lifted this container from a which lifted this height h from a y component, right? So now we know that there is an imbalance and the imbalance can be corrected with a centripetal acceleration, hence we equated it. Now writing down the equation, we have P naught plus rho yg times area minus P naught times area. This will give us the mass times acceleration. Now what was the mass? The mass can be calculated as rho, which is the density of the substance, this density of the fluid, times x times a. X times a is nothing but the volume, so it is dimensionally correct as well. Now we know that the centripetal acceleration for the center of mass is given by x by 2 because we are given a linear mass density, so it has a distance of x by 2 from the center, from the starting point. So x by 2 times omega squared is the centripetal acceleration. Now okay, so now it's time to solve this equation. We have P naught times area plus rho y g times area minus P naught times area has to be equals to rho x times area times x by 2 omega squared, which is the acceleration of the center of mass. It is clear that P naught times area cancels away. So and also this rho and rho cancels out. We have x squared, so y comes out to be half of x square omega square by g. This for us is now the equation of the parabola, and it can be observed that the equation of the parabola is for an upward parabola, which is pretty evident, right? So yeah, people, thank you for your time, and that was it.